there with them? With the animals? Somebody's crying. Did they wake up Maddie? No, you can go the fuck to bed. You woke up Maddie. Go the fuck to bed. Me? We're not calling her tonight. Please go get in bed, buddy. 1 2 checking 1 2 1 1 1 2 1 1 2 check check. Check check 1 2 check check 1 2 check check 1 2 check check 1 2 check 1 2 check 1 2 1 2 testing testing 1 2 testing testing 1 2. Turn off the noise suppression. Check 1 2 check 1 2 1 2 check check 1 2. I don't know if this is working or not. Checking, checking, that's way, whoa, that's like way so much. Checking, checking, wow, it's still too loud. Check, check, alright. What's up, guys? Sorry about that, I'm trying to get everything all sorted here. I think my mic is being a little bit weird here. I don't know why it's being like this, but hopefully you guys can hear me okay. Let's go to here, here. Okay, should be that way. Okay, I think we're good now. How's everybody doing tonight? Morning. You're way across the pond there. If you're that far ahead of me, jeez. Let's make sure everything here is okay. Yeah, alright. Alright, so I am working. You can see right here beside me, I've got my wee little printer that I'm working on here. It's coming along pretty good. I'm working in Fusion right now to fix a couple issues that I found in my initial prints. There's a few things that I'm not terribly happy with how they came out. So I'm working through those issues now and making the changes. Hold on to that so it doesn't flop around so much. But yeah, some of my holes were a little bit out of whack where they should be, I should say. I think it was mainly just on this side here. These both need to move up like a millimeter, I think it was. And then I have to reprint the lead screw side again because I broke it again. Second time, well, first time it printed poorly just because of orientation, and this was also an orientation issue because if you look here, where I put the holes are on the side, and that's the weakest point. So I've offset them by 45 degrees this time, and so let me pull that up for you guys here. We're going to Fusion, and here's my new piece here. Reoriented the holes. There's a little bit more meat in there now, so that's not so much of an issue now. Add a little more meat on this one, made it a little bit thicker as well. So hopefully, Australia, somebody from way the other side. It's tomorrow there, so yeah. But yeah, so I think this should be better now. All the other holes, I've tested a lot of them, and whoops, pitch that. They're tight, but they work. So. Is it possible to make a small metal 3D printer? So, 247, are you asking about like a full i3 metal or what are you talking about here? Because I'm only using just a few pieces of extrusion here. I'm actually using 3 pieces of extrusion. That's it. End up being, what was it? 850 millimeters. You could do it at 800, but I already bought the 1 meter, so 800 millimeters is what I am quoting in my build, but I cut this at 850, just a little bit more on the Z. But you can cut this as high as you want or as low as you want for the Z axis. So hello from Germany. What's up? What's up? So I'm gonna print the. I think I just exported, didn't I? Yeah. So I'm gonna go ahead and start the electronics mount. Alright, so we'll let the electronics mount work there. I think this is good now. I went ahead and opened up all those holes up a little bit more. Also, my captive nut holes were too tight for M3s. Let me check the M5 one. I need M5. That's a good tight fit. Oh, snaps right in there. I heard you guys heard that one. That was satisfying. Snaps right in there. Perfect, perfect, perfect. I'm happy with that. The other holes are a smidgen on the tight side. Some of these other ones. But that's okay. Parts are big, but they are pretty strong. I'm hoping they'll be strong enough for everything. I might as well just open those up just a tiny bit more since I'm already going to be reprinting this part. So we're just gonna go right on to here and do it. Let's hide this and hide this. If you guys have any Fusion questions kind of while I'm working here, go ahead and ask. I'm not a Fusion pro, but I've just been using it for a few years now. And it seems to be working out pretty well for me. So I'm just gonna open these up just a bit. Right now I think I did them as 5. We're gonna do 5.15. Oops. Want them to be big enough to let the M5 through, but not terribly small either. So we're just gonna go ahead and extrude this down. I'm going to pull this all the way through. I think I can cut both bodies at once. Yeah, it's going to cut both bodies at once. That'll be alright. Okay, on that. And I need to do one more right here. And 51, 1.5. Extrude, and then we're going to pull this all the way through here like that. Okay, now that'll make those a little bit bigger. The other one's already printed and it fits on the motor side, so we're actually going to assemble that one here in a few minutes, I think. But yeah, this one is good. Printed this a different orientation to make it come out a little bit better. This one I have to print on its back, on this back side here. So let's re-enable those, save this, and then we can re-export that. Save as STL. Z carriage lead screw side, yep. And then get the parts I need to reprint. So we have the Z carriage lead screw side. And we need to place this on its back. And how else? Oh, here we're doing. Oh, let me get back to chat. Sorry, I kind of went off the deep end. I got busy in there. So we have, how do I cut extrusion? Naim, I have a metal blade for my miter saw. I have a chop miter saw, and I just swap out for the metal blade. You can do it with a wood blade, but it's really not recommended. You need a high TPI, so tooth per inch. I forget, mine's a 40? No, it's less than that. I don't remember what it is, but anyways, I bought a metal one for it. It was like 15 bucks. I've used it a lot, so that's how I cut all my extrusions down. Makes it really easy. So somebody's asking, how do I do your joints? So let's go back into here real quick. Let's get my main model. So here's my main model, and as you see, if I grab my extruder here, I can grab it, move it all around like this. It's really fun. So it goes all the way to X and up and down on the Z, and then I can grab Y carriage and move it like this. So we'll have to start with a little bit of basics first in Fusion before you do your joints. And I learned all this from Aaron, so he helped me out quite a bit. Hey, Brandon. And what you have to do is kind of create your rigid group. So I created, over here, if I bring up my design space here, I created the bed by itself. And this is one rigid group. So the wheels are connected, the spacers, the eccentric nuts, springs, everything is, this is one group right here. And then in order to create your joint, you're just going to do assemble, as built joint, capture position, and you're going to pick the two objects that are going to move around each other. So these are going to be your, in order to create your sliders. So I'm going to select the wheel, and I'm going to select my frame of extrusion. I already have one there, so yeah. Well, that was rigid. So I'm going to change this to slider. And then the position is going to be, pick any one of the lengths, like any of the lines in the extrusion. And you can see how that wants to move then. If I press play to animate, it's going to go ahead and move. And then you go ahead and hit OK. And that's going to go ahead and create that joint there for you. And then when you, after you do that, so we're going to delete the duplicate I just made. You can go into, so you pick the slider you created. So this is this one. You hit this little edit joint limits. And this will give you some tabs to pull. So right here, these tabs. And it will move that one piece you selected. So if I zoom in here, I can pull this up to right about here a little bit. So right about there is where that's going to stop. I'm going to have to create, I think, something here to stop this a little harder, because I'm going to be using centerless homing. And then you grab this one in the back, and you can also move this one forward or back in order to get this to the position that you want it to. So this one I can actually go ahead and pull back just a few millimeters here. So go 5. So right now my travel on the Y is 189 millimeters. And I hit OK on that. It thinks about it for a second, and then now that is a hard limit on where it moves. The nice thing about this is I can also tell, oh, okay, I am still going to clear my motor here at that 189. I probably get 190. Probably ends up being on the Y. I just have to position the hot end in a way that it can get to it. But yeah, that's how much that is right there. So that's not too bad at all. I do need to move the... So I pull this down, see how far over there I am. I have to pull the whole Z forward a few millimeters, which for some reason I moved it back. You can see it's overlapping back here. But that is like the long and short of creating that. If you create any rigid groups, anytime you grab an object and pull on it, it will pull off. So if I grab this right here, these two pieces are together. They are a rigid group in its own sketch or its own design. So here's my Z end stop mount right here. And that makes it able to move as one piece. Also, if I grab this right here, that'll move. But my frame is grounded. Another thing that Aaron told me to do, you cannot grab my frame and move it. So once you create your frame, if you right click it, I unground it. So right click and hit ground, your frame will not move. That's going to stay. So you don't have to worry about like anything moving out of the way there. The one thing to go and check out is, or if you go to the Discord group and you go to the 3D printer challenge channel, we have linked a bunch of stuff in the pins, so you can actually find Lars Christensen's video on creating joints and the moving joints, things like that. He does a great video. He works for Autodesk for Fusion 360. I believe he's a developer on it. So definitely, you can definitely check out his video on how to do that, and that will help out quite a bit. He probably does a better job at it too than I did. I mean, I'm doing this live, so but he has an actual tutorial video on how to do that. But again, that's pinned in the channel for the pins for that, so check that out. Someone else was looking at Vention today as well, because a lot of people are like, I'm not too sure about like if I can use Fusion, blah blah blah. You can use Vention. Very, very cool program. I have not used it yet, but it's been highly talked about. I should probably turn on my other light here. A little bit more light there. There we go. But yeah, those are there. But yeah, so this is coming along pretty well. I need to reprint that part. What other parts do I need to reprint or print at all? So I've gotten all of these. I know I need to reprint this one. I'd like to assemble part of this tonight. Give it a whirl. I can't do some of the connections here because I'm actually tapping the. I'm gonna tap my extrusion. Oh, I need to change those up. Bob, that's what we're looking at. This is my custom 3D printer. It is not a Prusa Mini clone at all. It is just a mini cantilever crane style printer that I'm making for the design competition that I'm hosting here at a design challenge that I am getting people to have a shot at. But yeah, I'm waiting for my M5 tap because the Y idler and the cap up here are tapped into the end of the extrusion, and I need my tap to be able to do that. I think it might be here on Monday. I'm not sure though. That'd be cool. But yeah, so these feet here are off by just a smidgen, and I thought they were right on, but they're like maybe a mil too low. So it's hard to turn those because it's getting hung up in there. Yeah, I might bring this up a millimeter and then make that hole a millimeter taller. Hard to tell what to do there. Yeah, Bob, if you want to get in on it, there is a video I posted on Monday that goes over the challenge. So if you want to challenge yourself and your design skills, go ahead and hop onto the Discord and you can have your hand at it. Oh, son of a gun. I want those move. Yeah, Aaron, I actually have, I think I have it open. I think I have it open, actually, the 2020 jig. I just need it for 2040. So I think I can just hack off one of the four, because it has the 4 pegs that like go into the 2020. I just need to hack off that. This is also T-slot extrusion I have on right now. I want to see if it'll work, because it is cheaper, but I do have actual V-slot coming for it. I just figured I'd hack up a piece and mock it up, because I don't know when that extrusion is going to get here, and I want to have all my pieces kind of printed ready to go, so whenever I get the rest of the electronics and the V-slot, I can just kind of slice that down real quick and get this thing printing, or yeah, pretty much get it printing, because I want to have some test prints done before the 60 days. Thank you, Robert. I appreciate that. So get a little bit of background on what I did here. I took a lot of inspiration from the Ender 2, the Ender 3, a little bit of the Prusa. I actually might redo my entire X carriage, because the Prusa Mini, which I just recently imported in here, here it is, the Prusa Mini. It's only using one bearing on the X. So here and here, it's using one bearing each. And I have some LM8 LUUs, which are the longer bearings. And I'm thinking of that because if I can get my carriage to be thinner, then I can make my steel rod shorter. As you can see here, the steel rod goes 55 millimeters into the into the printed part. It's quite a ways. Actually, I need to go get my drill bits because this is still a little bit too tight. I'm going to make it a little looser in the model, but I'm not going to reprint it because everything else about it is fantastic. I'm happy with it, but these are just a smidgen too tight, and I'm just going to ream them just a little bit because once I get these in, that's it. The only way I'm getting these back out is if I cut this down with a, Dremel. There's no getting this back out, and this was printed upright like this, so it's not even like I can break the layers and get this out. No, there's no breaking any layers in this. This sucker is solid, and yeah, so I'm gonna go get my drill bits in a minute, which I thought they were up here. I thought they were up here. Apparently, I took them back outside. It can be, Robert. Let me grab one real quick. Oh, I guess I don't. These are 6s. Huh, never mind. Yeah, those are 6s. I also took a little bit of inspiration from the Hypercube, which is how I designed this to be very similar to the way the Hypercube is, of the way how he traps the hot end in there. So I'm thinking just because, yeah, if you look right here, oh, those are not lined up right now. I'll have to realign that. But anyways, this carriage is basically almost as wide as 2 of these. I'm thinking if I just use 1, maybe I can get by with it. Maybe. I'm not really too sure if that'll work or if it'll be too much play, because 2 bearings, and if you offset the actual bearings inside of them, you can keep it nice and tight and in line. That way your forces are equal. If you have both of them the same way, you'll have rock in your bearings. But if you offset them, canter them a little bit by 45 degrees technically, so that they are, there's 4 channels of bearings inside of these bearings. And if you just offset all of those so they're all counter each other, you have equal force and you have less wiggle. That's a long way of saying I don't know if I want to go down to 1 or not. I might design it, maybe print it and see if it works. This is going to be my final right here. This is what I ended with. It's just this comes, I mean, way over to get to the end, and it's just enough to get. It's a smidgen too long, but that's okay. I mean, I'd rather be a few millimeters too long than too short. Well, I did not group that. Let me go back here to my Mks carriage, and I need to just do a quick rigid group here. Okay, now I can move that around without it moving on me. But yeah, so the whole goal there was to this Z probe is actually not. It's not going to be in the final. It's not going to be in the product that I print. I just made it available to be able to. So I added the ability to do this little mount and then secure it to the carriage and kind of go into there. I added that, but it is not really that necessary. I also think I need to make these a little bit bigger because the ones I just printed are a tad small. I thought I made those big enough, but apparently I did not. So, at least in PETG, they're not big enough. So I do need to correct that as well. I also need to, I redid my Z motor mount. I've got my little boogie board here to do that. But yeah, I think I'm going to go ahead and, that's printing. I think everything else is printed and ready here. I'm going to fix the X carriage, and I'm going to print the X carriage. I also went ahead and I literally just finished this. A little cable clip thing. It's not the sexiest looking thing in the world, but it'll definitely work out. And basically, so my wires, the Z-probe come over and go up here. The hot end and thermistor and the fan power cables will all loop here, come up, and then these are zip tie holes that can just go through there and zip. And that's also how my bearings are on there. My bearings will be zip tied into place on this version. I did cut away a little bit of material here on these two sides, again trying to save a little bit of weight. It's not a ton anyways, but it does save a little bit. Say later X Unite. So yeah, let's make these a little bit bigger. Let me find where that sketch is at. Not that one, not that one, not that one. I don't know how far back I made those. There they are. So yeah, 2.25 is too small. Let's do 2.5. Change this over here to 2.5. There's that. And there we go. So it'll be a little bit bigger. We'll be able to get those to fit in better. Yeah, cable management is always just the worst. Oh, L3D, you say making a 300 by 300 300 IDEX coaxial wire. Oh, very cool. The IDEXs are pretty cool because they have the dual independent extruders on there, and those are very awesome. They're very expensive though to buy. That's the one thing that kind of sucks with them. It's super expensive to buy. But if you can build one, I'd really like to see your design. That might be pretty cool. Yeah, so those are bigger now. This will print flat. I'd love to do that without support. I might print it once without support and see how it does in bridging. But I'm not too sure because it didn't bridge very well in this original version of the motor mount. So, just kind of wondering what to do with that. I guess I can just do supports and pull it out. It shouldn't be horrible. Yeah, but I think that's it for this piece then. So this should be good. So let's make sure we save this. I need to make all of Oh, that didn't. Where's that group's at joints? That did not bode well. So let's do this with that. We want to do a symbol joint. There we go. Okay. Now that should be able to save, and then we're going to export that back. I already have the front piece to that. Yeah, the actual clamp I have. I just need the back carriage part. Yeah, that's right here. So save as STL. Okay, and this is just going to be the X carriage, just X carriage. Yep, replace that. And then Prusa slicer, X carriage. Lay you down on your face like that. I guess we're gonna let it bridge because I don't want it to put support in the inside the logo there. Yeah, I'm just gonna bridge that, which is fine. Yeah, that will have a little bit of droop in it, but maybe I should add support enforcer there. Yeah, let's do that real quick. So here, support enforcer, box. And down. And then move it down. Right to there. Slice that again. There we go. Just get a little bit of support under that piece. The rest will be fine. Not worried about them. And those will be fine. They're too hard to get the support out anyway, so I'd rather just have a little bit of drooping in there and call it a day. And then this all should print okay like that. Might actually be a little too close. Might need to make those holes smaller. Because I made them... Oh, it's the bearing, Brandon? Oh, L3, you're going to get a Nova hot end? That'll be interesting. I have only seen a little bit from Chris Warkowski on his, and I was surprised that the quality of it is not as good as it is advertised. So it seems very expensive for what it is. If I was going to build like a high-end machine, I'd probably buy a Mosquito, but again, you're still being a little bit Sharpie as support interface. I'm not sure. Joshua, what's up? I've not seen that L3D. What was I just gonna go grab? Totally just lost my train of thought. Oh, a zip tie. Because I think I made my holes too big. And if I did that, then... yeah, so those are 1 mil, and I made those 1.5. And I made it 3 mil wide. So I might make those a little bit thinner just because of the way these turned out. Yeah, I mean, these are just... I can make it a little bit thinner there. So instead of 1.5, let's do 1.2. Oh, you stupid thing. Now take it outside a little bit more. That's better. 1.2. Same over here. 1.2 here, 1.2, and then we're gonna grab, nope, cancel that. That and that, we're gonna move these out a smidgen, like that. I think that'll be good. Ooh. I am going to go see what that was. I think the cat or something. I'll be right back. All right, sorry about that. Oh, you already have two. Oh, cool. All right, so I need to roll this back a little bit. Okay, so I think that is a little bit too big. Yeah, I need to make these, if I'm doing 1.2, so 0.6. 0.6. Oops. 0.6. Oh. Oh, there's a constraint here. Delete that. 0.6. 0.6. Let's finish this one here as 0.6. And then finish that. Okay. Now that's a bit better. So there's one thing no, it was the kids. One thing I've been figuring out, something that Aaron said, is that everything looks enormous when you're zoomed in like this. And when I print things, I'm definitely seeing how not enormous those parts are. You start worrying about the smallest details ever in your part, but when you actually print it, it's nothing. It doesn't even matter because it doesn't even print, or it's just so small. It's so insignificant in the actual part, and definitely figuring that out. I mean, I've designed things in Fusion, but never anything this intricate or mechanical. It's usually a lot of like, oh, this thing broke, so I need to try and fix it. Like, it's things like that. But yeah, so now let's save this and re-export this again. So save as STL. Yep. X carriage. And I say that because if when I go to slice view here, you can see there it doesn't even it only does like 2 layers, and then it has an open gap there. I don't want that open gap at all. So I want to let's delete this. Yep. No shit. Remove that object. Now let's import the X carriage. Okay, and then we're gonna lay it down on its face. And we're gonna go ahead and rotate it 90 degrees, just so it's in line with that one. It makes me happy. Arrange now. It's sliced now. And there, we actually have it sealed now. There's no gaps in here anymore, and that's much better. We still have our space in the back to bring the zip ties out, so I'm liking that much more now. Yeah, he is good. He's taught me a lot, so I'm hoping that this time I went ahead and fixed this, so now there's got a lot of meat on the side here, so hopefully this part won't break again. I also made the center hole for the lead screw nut to have space. Cat went in the bunny's cage again. Hey, Dan. I didn't say a bad word. So yeah, well, I guess we're gonna see how this turns out. I mean, I want to make sure with no other parts I need to reprint or print. Oh, I need to add the. Well, let's just look through here again. Let's go to the main model. Close this out. Save this. Let's refresh. X carriage needs to re-import again. Oh, great, that moved, but none of these other pieces moved. Alright, we'll go back and fix that in a minute. But this is good. No, I need to re-enable that. save it. Get out of that one. Get out of that one. I think Z carriage is good. Got a little logo imported into this too. I like that. Yeah, I'm liking that. Alright, let's fix this real quick. Oh, you can say that at least a couple times. I remember Linus talking about it. See if that fixed it. Made that a rigid group so that it can't move. Refresh one more time. Oh, I'm gonna have to redo it. Shut him a gun. Alright, cool. Someone's asking me how to do the joints, so I'm gonna do this live for you here. So we're gonna do a align first, a modify align. We're gonna pick the inner point of that bearing. We're gonna scroll down here. We're gonna pick the X shaft. Do that. Boom. That aligns that right up. Hit OK. Now we're gonna go ahead and create the slider. So assemble, as built joint, capture position. Change this to slider and do the bearing and the shaft, and then click on the shaft again and one more time. There, it's sliding now. And then we need to set up our, so now it's locked in there. Okay, so I'm going to move this all the way to the minimum point it can go, right about there. And now I will come here. And then we're going to hit the little edit joint. We need a minimum and a maximum. So we're going to grab the maximum over to this. So this is as far as it can go. And that's 142. Hit OK. And that is how far we can get. So we have a total of 142 millimeters of travel on this. Oh, I didn't change the minimum. That's not right. So yeah, see, the minimum jumped on me. Minimum moved right there. So I need to move this. Let's go to there first. The one hard part about this is just kind of figuring out where that goes to again. And that's, wow, that is spot on. That is literally spot on. So there's our total travel there, right like here. I think that looks fantastic. I think it's moving well. Oh, I didn't print the end stop. So I will export the end stop here. Let's close all these up. Z end stop mount, bodies. Yep. And then we're going to save as STL. Okay. Z and stop. Prusa slicer. Let's pull the end stop in. Right there. Lay it on its back. Arrange. Slice it. Okay, let's add that enforcement back in again. I guess that's also good for this because a lot of people don't really know how to do that. It took me a little while to figure it out. How to do support enforcements. Support enforcer box. And then we're going to do the size of it. Move this again here. Like that in there all the way? Nope. Like that. Now if I hit slice, there we got support in that one right there. Because need that to be nice and flat. This up here won't matter because you're not going to see that behind the cables. It also should make that easy bridge. And then yeah, this is my Z end stop here. I think that should be all right. Let's export the G code to here. And then let's go to, where do I have Canvas at? There it is, Canvas Hub. We'll upload it. Where to put it at? That's on the desktop. Master Crane, G code. And 9:15 p.m. There it is. Oh, Eduardo was asking, how do I move the parts? I just showed you how to make the... You have to make that pairing into a rigid group. And then, hang on. Once those parts are grouped, you can then create the joint. And with the joint, you'll be able to move your parts. Like I said, you can just grab onto your hot end here, and you can just pull it all the way along your X, all the way up and down your Z. And if I zoom out, you can see my Z stops up at the top there, goes all the way down, and then the Y moves as well. So it's 184, and that is 5. So I get 189 on there. It should be about 189, 190 cube. The build plate is only 166. So I'm getting a little bit of extra movement, which is, again, is okay. I wanted to use kind of round numbers for cutting. I didn't want to make, oh, cut it at 283 millimeters. No, cut it at 300. You're not saving any money by cutting something like 7 millimeters longer because you're not buying extrusion that way. So it ends up being just fine. This build is a one single stick of 800 millimeter 2040 V-slot extrusion. That you can build this whole printer with just that, and then two 300 millimeter smooth rods. So that's the only really metal parts that you need for this build. Everything else is 3D printed, which is great. Well, I guess you need the lead screw. Sorry, the lead screw there. And mine is just a little too long, which is great. Hey Dimple, this is the custom printer that I have designed for the 3D printer design challenge that I'm hosting here on my channel. So if you haven't watched that video, on Monday is when I posted that. You can see the link down for my Discord, and then there's a 3D printing design challenge channel there that you can go for more information on it, and where everyone is kind of getting together and collaborating. I've been streaming live almost several nights a week just on Discord with a bunch of people that are designing printers, and there are some fantastic designs coming out. Aaron's, he's been doing a lot of this with me and showed me a lot, but his is looking pretty sweet. Someone's doing a Core XY, which is pretty cool. Actually, there's two Core XY builds for $130. That's the other thing I didn't really say that here. So the 3D printing design challenge is you have to make a printer less than $130 US. I said 100 in the original video, but since we're going off of the Easy 3D X2 3D printer, that's the one that everyone's reviewing right now. It's $130 US on any website, pretty much. Amazon, AliExpress, GearBest, Banggood, all of them. $130 US. It's 100 millimeter cube volume. So the challenge is, I want you to design a printer that is $130 or less, and two, has to have a larger build volume than the X2. So mine is going to be roughly a 160 or 180 millimeter cube, roughly. I think it's 166 actually what it is, because I bought my build plate here is a 7-inch by 7-inch piece of 3mm aluminum that I bought. Yeah, Brandon. So X enter. Let me look at Discord real quick. What's his name? 3D printer design. Yeah, the X enter X4. He's the guy out. He's the German guy. He is doing a Core XY, which is, it's going to be pretty sick. We did criticize him though, because he does have a 400 by 400 printer that he is utilizing to make it. I said that's the only thing I can dock you for, is that you are making this way too hard for anybody else to print. And the thing is, the reason why I set the price goal is you have to have a BOM list. So if I go right to here, here's my BOM list for this. I'm at $131.16 with a Z probe. The things that we're not counting is any hardware, which actually I think, do I still have those? Oh yeah, the corner brackets. I got rid of the corner brackets because I 3D printed it, which is right here. It's already been 3D printed and it's already on there. I do need to delete that line, delete row. Look at that, 129. I'm under with ABL. That is not too bad. Hey, Gunner. Yeah, it is possible, 100% possible. We're not counting fasteners, so nuts and bolts are not counted, and we are not counting filament. So, I forget, Brandon, but it's gonna no, it's capacitive, so it'll work with any surface. This I went ahead and. It's going to have a removable build sheet. So that's one thing that I'll say I don't think I told everybody. But the X2 has a removable build plate. And there's a lot of people that are not going to have that. And that's definitely a feature thing there. I am going to have one. I think it'll be pretty sweet to have. I'm excited to actually be able to do that. But it was very cheap. I went ahead and bought a larger one because they're way cheaper. And then I'll be cutting it down. Hey Viking, you can always scale it down and submit. So again, with this challenge, there's 2 types of entries you can have. There are going to be the people that just submit a 3D design. So like if I receive this from somebody right here, I can grab it, I can move it, everything works. This would be a great design from somebody. And then there's another group of people that are actually going to be building, which obviously I am building mine. And it's, again, this is not expensive in any way, shape, or form. It's very, very cheap to do this. And you got to do your homework. You got to know your parts and things like that. So I think it'll be a ton of fun. I am going to run real quick and go and find my drill bits because, again, I think they are downstairs, and I would like to kind of mess with some of the assembly of my motor and things like that on the X carriage. So I will be right back. Give me 1 minute. All right, I got it. Got it ready here. Yeah, Niam, I saw you with that $50 bed. So, what is the closest Freedom unit to 8 millimeters? So 5/16 is that. So what's 1 up from 5/16? 21/64. Yeah, That'll work. Better. Oh, yeah, I'll be able to get all the way now. That's pretty good. No. Alright, so I got my. Is that all the way in? So all the way in is. That's how far in we gotta go. So that is to right about here. Get the other one in there now. Oh, that one's still a little bit too tight. Oh shoot. Yeah, once I get these in, getting them out is kind of brutal. Oof. Oh, that one's in there all the way now. That one's done. Rip. Oh, man. Yeah, I don't know if I can get that back out now. I just have to hammer it in and go from there. Yep. That's in there. Those are not coming back out now. And then I have my X end here. Here it is. So this is my X end and idler. We'll go in here. I guess I can go ahead and install my idler. Honestly, it's a little on the tight side. Yeah, that definitely rubs a little bit, so we're going to have to edit that. Which is good, it's a small piece, easy to edit, but also my M3 in there is tiny. So we need to roll this back a little bit here. We need to get rid of that part there. Let's make that. I said that? No. Okay, let's leave that at 6. Need to make this a little more see-through. And then let's cancel that. Now we got space. Okay. So we have to hit it back to 100%. Now where is that sketch at? There it is. Alright, so this needs to be, we'll do 2.5. Finish that. Yeah, because what did I say these are? Back to millimeters. Oh no, these need to be 2.8. Oh, I made those too small. Shoot. Where's that sketch at again? 2.8 millimeters. There we go. Now that should fit. Yeah, because I made that 2.25, and like that's barely even the head of this thing. It's tiny. So, Gunnar, will that work for PETG? So I've warmed up PLA parts, but I've never tried PETG parts, and these are all PETG. So this one's definitely need to set aside, but this one here, goes right on there. Just like that. Not too shabby there. Let's get a motor. Good like that. We need to put an idler on it first. So I get this. That's too small. But then that's too big. It won't be captive then if it's 3.5. These have to be captive. Oh, this is that one motor that. Oh, super tight, isn't it? Yeah. Or is it the bearing? No, it's the motor. Oh, shit. Different bearing. Pulley, I should say, not bearing. Nope, so let's make this one. Should probably use it for the Z instead. Which is, I only have these beefy ones for Y, so it's going to be a beefy motor. Hopefully it doesn't mess with that. What to do here, what to do here. Alright, we're going to take the Y motor, since that doesn't need to be so precise. Let's fit. That collar is huge on that. Let's see. No, one side is the screw coming in. This is the bolt head. Sits there, and then this side is for that. So, actually, while I'm here, I'm going to go ahead and make a... how big is the M3 head? I think it was 4. No, it was 5. We'll make this 5.5. And we'll go -3. There, so that way you can hide that that screw away completely. Don't forget the bearings. Oh, you mean on this? Oh, I can take this off. It's not a problem. This pops off the bottom. Again, I just kind of wanted to be able to visually see how this is all going to turn out. Oh, that's how I did Yeah, the one downside of the way I had to design the Z motor mount is I can't slip it in. So I actually have to take the Z off to be able to do this. I might, once I figure out exactly where I need this to be, I'm debating on doing kind of like how all the standard i3s do these days and drill holes straight through the lower extrusion and tap the bottom of this Z extrusion in order to capture it that way. This piece here is spot on. There we go. So make sure this one goes on okay. Do not. It's better than the other one was. The other one's basically non-existent. Alright, so we'll put this motor in here. That's going to be fronts that way. We're going to run this inside here like this. And we can just pop this back on. Like so. There we go. Now we're cooking. This will be released eventually. I guess I could switch to... Sorry about that. Hang on a second. And copy. I just made this this right here, so I forgot to copy my mic over. Sorry about that. But yeah, again, I was just saying it's interesting to see where your shortfalls come into play, of where you didn't think about something properly and how that's affecting your design. Ooh, that is really close in there. Really close in there. Should have made this maybe a millimeter thicker now that I'm looking at it. Come on. But yeah, so if this is going to be, trying so you guys can see this. This is the front of the printer here, like this. And then this will be the X that goes across there. And so my X motor is coming out the front. That was the best place to put it. And now I just need to fasten this in. So I'm gonna need to get out my M3 catalog. So, oh gee, thanks, Gunner. Ooh, wow, these are fitting, but they're a little tight. Yeah, those holes in here are a little tight. Need to open those up a little bit. I'll do that here in a second. Once I make sure all four of these actually line up. Trying to make this easy on myself here. It's I'm going to order a different power screwdriver. Because I'm not happy with this one anymore. It was really good when I first got it, but there's better options out there now. There's the motor on there now. It's not too bad. Hey Chris, just designing and fixing things. So while I'm thinking about it, let's go over back into Fusion here. This one, there we go. And I probably need to fix those too, because those are also probably wrong. Yeah, those are. 2.8 and okay, let's just redraw that one. What am I doing? Polygon. Those both going the right way? Yeah. 2.8. And we will delete out that one. There we go. So now those are big enough because I screwed that up. Let's go ahead and add on here as well. 5.5. Let's do here and do -3. And make those recesses as well. While we're at it, why not? Save this out. Yeah, that's much better now. So I need to the X tensioner, save as STL. So we're just gonna X tensioner and lay you on your face. And yeah. So we've got that piece ready now. Save that. Alright, now Get out of the carriage now. Well, let's go to the, what does I need to fix? Oh, that's on the Z. Where's my Z carriage? And we need to just gonna make all of these a little bit bigger here. So that's 3.1. 3.1. Because I actually just extruded that up from the top of the motor. So obviously those holes were too small. I just didn't think about it. And then we're gonna do 5.6. Just give a little bit more clearance for the bolt. Alright, so now we can, let's turn off some of the stuff here. The wheels can stay. Yeah, turn that off, and then turn off that one. There we go. So 1, 2, 3, 4. Pull that all the way through. Okay, and then turn that sketch back on. Where did sketch go? Oh, sketch 2. Really? Oh, I need I lost it in isolation. So do that. Okay, why can't I? It says it's sketch 2. That's definitely not sketch 2. Yeah, most definitely not sketch 2. Maybe it's because I isolated it? I can't reselect it again? Wait, it's bigger here. Sketches. Oh, there we go. Sketch 2. And we're going to extrude. That, and that, to object inside of there. Okay, there we go. So now we've got a bit more space on there. All the way up, back up here, close that. Go there. And let's update this. There we go. Turn that back on. Turn that back on now too. Save this. There we go. That is better. So, yeah, so now for whoever gets the final version of that is definitely better now. Let's see here. Kings, yeah, this is so this is part of the design build. And yeah, I think I had to spend, I guess maybe like $40 or $50. I think I had to spend on it. I mean, obviously I'm building most of it right now, but I don't have all of the parts yet. is a beefy motor off the X1 that I'm reusing for this. Or is that not the X1? Off of the Alpha Y, yeah, the Alpha Y's U10. Oh, as always, dropping stuff. So a couple people did ask me why the change in price. I thought it was a little unfair to do. If we're comparing it against the X1, and they had $130 to spend, I figure everybody else should have $130 to spend. And there were a lot of people having a really hard time to hit that $100 mark. So I figured, you know, we'll go ahead and make it a little bit more, and make it a little more accessible. Go. I just need to tighten this up. There. Yeah, I wish I had a smaller motor to use on that, but it is just taking it. That. That's fun. Yeah, this is looking fantastic. I'm liking it. Well, also, Chris, I mean, they're using injection molding, and while injection molding is expensive, it's cheaper once you make, you know, tens of thousands of something. What does it say about the Ender 3 plate? I didn't say anything about Ender 3 plate. Sorry. Oh, I'm the best. So you're saying you want to reuse the plate. So you can, but you'll need to price it out. So the whole thing behind this is, yes, people can use, and I actually did a, it's not linked here, but it is linked in the channel. Aaron and I did the kind of like a pseudo live stream, and we kind of went over a lot of the questions that were coming up, and people were like, oh, I just want to reuse my things. Like, well, yeah, by all means. I mean, this is aimed at people that have already built, you know, 3D printers and have the parts kind of hanging out to be able to use for this. But the one thing that it was asked is reusing parts. You can, but you need to price it out as new. And the whole reason for that is that if someone likes my design, I only need to buy the board, so I need to buy the board, the extrusion, the screen, or I could use a screen that I have here, but I wanted a different one, and the aluminum plate and the heated bed. So what, 4 or 5 things that I need to buy to build this out of everything else I have, but yet my part list is still complete with everything you would need to buy if you were buying this brand new. Because again, if you say that you want to build this and you don't have any of the parts, well, you're here on my list, and here is a $130 list to buy and to make this printer. The only thing you need to have are the screws and filament to be able to print it. I mean, because even at that, I mean, filament alone, to buy a roll of PETG, then... Yes, correct, Gunner. So this is a completely custom design. These parts do not exist online. They are very similar. Yes, this Z is very similar to how many printers have done it, but I designed it myself from scratch. You can always get inspiration from other things. I am using the way that I'm doing this spacing is the standard 44 millimeters for an i3. Prusa's using, I think they're using 34 millimeters or 35, and then Prusa Mini. But this is what I decided to go with. You can borrow ideas from other printers, but you still have to create all the 3D printable parts yourself from scratch. So this is going to go, so if we're looking at it this way, that's going to go just like there. Just going to fit in there. So I need to also figure out how long my M5s need to be, because I have some really long ones. I might need to cut them down. They might end up being too long. I think I have 50 mil is the longest I have. I think that'll do it there. Yeah, I think that's pretty good. I'm using TPU feet. It was a design that Aaron had originally made for the Megatron, so I kind of adapted the way that he does the feet. They insert their small little 3D printed TPU parts that just insert into the bottom of the foot, and it's nice. It's a snug fit. Wish it might make it a little more snug, but double hot glue will do it there. So yeah. So I can't do the hot end or the Y, and I'm waiting for the power supply to come in. I have my power supply case already created here. It's actually going to be sitting like this, so hence why the logo goes that way. But this is going to go on the back side of the power supply. I've got where my wires will come out. And again, this was a very simple design because I just made one for Megatron. This was really easy to just recreate. I just pulled a power supply into Fusion and then modeled around it. And the hot end parts, the wire idler. This is the top part just to kind of round that off up there, not have any sharp corners around. I have not built the LCD at all because I found a drawing for it on the MKS on the MakerBase AliExpress page, but I don't fully trust it. So before I go and actually print that part, I'm going to wait. I also did redesign the Z, but I'm not going to reprint that, but it's in here for anybody to grab. So this is being will need to be reprinted. I need to set that to the side. I do need to reprint my part cooling fan. So this came out pretty well, but where's the 5015 at? Actually, I haven't even tried this with a fan, see if it fits. Shit. Oh, it fits. It fits. Just like that. There's right there, and I've got all the holes in the bottom. Now, this is a little thin, so I did remodel it and just add an extra millimeter onto the base of this to give it a little more oomph to it. But I haven't tried it yet. I have no idea how well this thing's going to work, if at all, to be honest. So we're going to find out, and it just locks into the front of the hot end carriage. Just kind of links in right like that, and there's a slot for a square nut or for a regular hex nut to slide down in, and then this will lock this in here, and that won't go anywhere. Very dad of me. But yeah, so this will be good. Have all the wheels I already have, bearings, the BMG. I already have the extruder prepped to go. Should be alright. That's why I didn't put the gear on it yet. That's what I'm missing. Thought I was missing something when I put that together. Didn't put the gear on it. I mean, I just put this together now. I have to take it apart anyways because I'm running some very long M3s through this. It's going to go through the actual carriage, through the BMG, into the motor to hold all that in. It should hold up all right, I guess. Pull this out so I can line up the gear. I did think about, well, Aaron did design the way the Prusa Mini has their extruder. He went ahead and was able to reinvent that and get that working in his design. So after this is all said and done, I'm going to borrow his design. I was going to try and create it myself, but creating the geometry inside here is a little beyond me, I think, for right now. So I'm not going to try that, but he said I could have his design afterwards. And I'm going to go ahead and do that on it. What did I do with the box? Oh, there it is. There's fine. Oh, it's small. Not even going through. It's very strange. Oh man. Oh. I'm just stripping it. Shoot. Does not want to tighten down at all. So we're going to get the iFixit kit out and see if we can fix that. Too big. Too small, of course. Oh man, I think I'll have to buy another one of these because I just stripped this out now. Hey Chris. Well, the grub screw didn't want to tighten down, so I tried tightening it down and it stripped it. It doesn't want to go through its own hole. It doesn't want to go to its home. You want to go to your home? Well, that's definitely not going to do anything. Yeah, that is stripped now. Son of a gun. Gun. Nope. Shoot. All right, got it out. Okay, You suck, so get off of my tools. Well, that's gone. Maybe. Here it is. Alright. Let's see if I have another one that'll fit. Set screws. I have some other screws here that might fit. I'm kind of a hoarder when it comes to certain things, and set screws is one of those things. Now, where did I put the gear? Oh, it's still on there. Haha, okay, this one works. There's the flat side of the motor. Right there. I can't do that. Nope. Shoot. Strip this one too. It's the threading on it. That's the problem. Threading is junk on the set screw, and I don't know what size of this set screw is. Is it an M3 or an M2.5 or what? Oh, come on, just come out for me. Come on. It's because it's not tapped straight. That's why. Tapped at an angle. Well, I could always get the Dremel and cut a slot in it. That's too big. Yeah, for the most part, most problems can be solved that way. This is buggered in there now. Good again. Ouch, that stabbed my hand. This is not going well. Not going well at all. Sorry if I stab myself in the stomach, I'll be pissed. That's way too big. Try different bits, see if I can get anything to bite in there enough to pull this thing out. Not going well. That's not gonna cut it. I have to use a Dremel. Shoot! It's always something, isn't it? Something's always got to be the setback. Where'd it go? I know. Trying to be careful here. It's just not. I can't really get a good angle without endangering my stomach here. I don't have a vise. That's one of my big problems. I don't have a vise. I don't have lock channels either. I wish I had some lock jaws. Add to my Christmas list. That didn't do it. Hey Vince. Come fly down here, brother. Really don't want to ruin my bit set here. Doesn't fit at all anymore. Fit. Oh, that's what it was. None of that's going to work. So I'll hop online now and order another one of these. Man, oh man, wish there was an easy way to do this without making a lot of noise at night. I can almost get this star bit to bite, but just not quite. If I can clamp it down to my desk here. That did it. I got it. So I clamped it like this on my desk, and that worked. So what are the threads on this, I wonder? I think it's an M3. Where'd that clamp go again? I'm going to use an M3 to kind of make it. No blood. Right, let's try another one of these set screws and see if I don't bugger it up again. If I feel resistance this time, I will stop. Where'd the screwdriver go? There it is. Back. Nope, goes all the way now. It is M3. Okay, all of that just to get this onto this motor. Okay, that's on there now. What are the things I do? So that's going to be with that face downwards. Although I'm going to have to reverse that because they bump into the rised part. So where I lose everything. Now it's stuck on there. I didn't put on that tight, dang it. For this exact bloody reason. No, it's tapped all the way through now because I ran an M3 through it. But now it's stuck on, and I need to flip this stupid thing over. Clamping to my desk really helps. Should have did that in the first place. There we go, come on. These the grub screws I'm using are also pretty much junk, I guess, because they're not really holding up at all to this. Jimmy, I ran an M3 through it. Where puts that M3? I definitely think it's tapped at an angle. No, I have to flip it over. I don't want it that secure. It needs to be able to come back off. Definitely some form of junkie. I'll tell you that much right now. I'll order a new one of these. Because this cheap aluminum that they use is not that good. One of the things to watch out for when you buy the cheapest thing you can, you very well could have issues just like this. Alright, well that's on there, but I can still get it off, so. No, I couldn't because the bottom part of these, see how it's flanged? That needs to be down here in order to mesh with the gear on the Bondtech. Now it meshes perfectly fine. This way. It's going to be going downwards. See if that works now. Get rid of this. This thing binds up. This one's really crap. I don't know why it's binding the way it is, but you can't even rotate the thumb wheel right now with that motor in there. Ouch. Oh, that wire, that's not going to work with it down there. It has to be the other way. Basically touching the motor. Alright, well. clear it or not. Oh, because that's why my grub screw is longer than the one I took out. That's why it's having an issue. Because their grub screw is junk, and mine is too long. So, I do have an itty bitty one here. But if this gets stuck, there is no turning back. Okay, that one's on there now. Now it'll work. Now we're cooking. And we're not binding anymore. Okay. Figured it out. Alright, so now we've got Bond extruder that works. So hoorah. Am I the only one that hates the idler spring on, or just the tension spring on Bontex? The worst thing in the world to get threaded. Here we go. Alright, so that'll go. That's going to be popped on the back like that. But I will order another one of those tonight, just in case something happens to this one. It just dies on me. That grub screw is trash, so it is not a real Bondtech. Yeah, every printer I ever disassembled, I kept all of the set screws from it, and I've kept all the spacers from them, because there's no reason to throw that stuff away. It's very good to keep around. This is a cheap 3D printer build, man. There's no way I'm gonna put a, what is it? What do these actually cost? The gears alone are $50. They're like $90 or something like that. That works out well now. All right. So, yeah. Short little set screw. also have an old. I was going through my stuff, and once upon a time, Triangle Labs was a thing, and they sent me a filament runout switch. So I thought, maybe I'll once the competition's over, I will add this on. I think. Why not? Have filament run out then on my printer. Don't know where I'm going to put it, or how I'm going to mount it on here, but sure, I'll figure something out. But yeah, I did find that. There's some tough tube from TH3D here, which I never really use. It's Bowden, don't really matter. I generally just use the cheapest Bowden tube I can find. Never had any issues with it. So. And then I have a regular nut to use, but I also have an anti-backlash nut to use for this, which I'm pretty sure their hole patterns are the same. Yeah, it looks to be about the same. So they'll both fit, but the actual one's going to be that. Got all my bearings here. I have more lube coming in, which I think will be here next week, maybe? That'd be nice. Well, $80 for the extruder. Thanks, Gunner. Hey, Thomas. Stuff from Triangle Labs has been very hit or miss in my experience. Oh, I'm going to have to reprint this too. Because again, I made the captive nut way too small. So let us fix this. That's on the y-axis. Let's see where the sketch is for that. Nope, not that one. There we go. 2.8. Finish. There we go. I also had to make these holes in here bigger because again I'm tapping straight into there. I might end up having to come back and put a little stopper on here just so the wheel doesn't hit it. Maybe I'll just do that now. Let's just let's do create a sketch on here. Doesn't need, oh, that's a circle. I want a rectangle. Doesn't need to be anything crazy. Let's just extrude final off of that. Only problem is this no longer makes this printable without support. So we're just gonna leave it off for now. I'll figure something out for that. Maybe I'll put something in there and a 3D printed piece or something. I don't know, but we're gonna leave that the way it is right now. I also did create a Y tensioning system here. So this is multiple parts here, like this, and the idea is you would run an M3 back here to push this front one forward. I did not print this yet. I don't know if I will. Might print it in PLA just to see how it works out. I also did not add any clearance in it whatsoever, so it will not fit in the way it is right now. But I was just trying to figure out some type of belt tensioning for the Y, and that was the best thing I could come up with. So for now, we're not going to worry about that. We're just going to save this STL out, pull it into Prusa Slicer, so the next time that I print this, what was that, Y idler? Yeah, so then I can reprint that again. Let's see, save this one more time. Oh, I need to turn off the frame. Now I can save it again and update my design, the main design. I printed that, right? Make sure I was printing that Z end stop. Yeah, all the idlers are 20 teeth. Because 16s I don't think will make the bend of the extrusion here. So the way this is going to work, let me throw it up on here. This might be easier to see. So the way the belt works, just like an Ender 3. So you'll have this idler goes here, like this, and the pulley sits in here, and the top belt will be connected to the gantry, the Y gantry, and that'll move back and forth here, the Y bed, and it will slip through here, this hole here, go through the inside of the extrusion, come over the back belt into the back side of the bed. So I'm utilizing the inside of the extrusion there as a pathway for the belt. Because that's exactly how the Enders use it, except mine just looks better. And it's also 3D printed, it's not aluminum parts like they're using. So it's not, obviously not going to be the same, but it definitely will be better. Yeah, I'm really liking how this is turning out. This is turning out to be really, really fun. Again, 3 pieces of extrusion. This is actually way stronger than I thought it was going to be. I'm using 3 perimeters, 20% infill, PETG, and holy cow, those are strong. I'm going to move all those holes on here up a little bit. So because these are just ever so slightly too low. So let me turn off the y-axis. Where's it at? Y-axis. They look like they're in line, but they really don't feel like it. See, if anything, those are a hair too tall. Yeah, I think these ones need to come down a millimeter. These inner ones here. Gotta find that in here. Let's see here. That's when I did that part. That. That's definitely not it, because I took out those top screws there. Oh, finish that. Stop. Stop. I need to get a new mouse. This one's just been double clicking on me. Here we go. Here. So we're gonna make this 4.5 finish. And I think it was before I mirrored it, so back here should look the same. Yeah, okay, yeah, because I mirrored this axis, so if anything I change on the front, we'll change it on the back inevitably, so that makes it a lot simpler. The 8mm linear rods are 300 millimeters long. Could I stand on it kind of strong? Probably. Yeah, I can't see why I wouldn't be able to. So the HP plotters I used to work on is a spring-loaded wedge pushed on an axle shaft to maintain tension. So yeah, I mean, Uncle Ron, it would. The only, I mean, basically what a lot of people are doing is, I mean, if you look on Thingiverse, let me pull it up here real quick. I'm not saying do it now. So a lot of them are using like a screw design in order to to do it. Like a lot of them. So what it is this is your carriage here, and then you're just pulling it away from the belt to tighten it. The problem is that I don't have the space. I mean, I do, but I wanted the front to kind of look, you know, nice. You know, lack of a better term, a little sexy. I wanted it to look appealing. And having a big old knob screw on the front is just fugly. And I also don't know how to make the threads for that. And two, building something like this would require this huge, bulky thing in the front. And I also wanted to avoid that. I didn't want to have any bulk up there. So that's been, you know, that's the one thing that kind of annoyed me. And this is little, I thought I filed this up here. But that's the whole reason why I kind of went the route I did. Because honestly, if it comes loose, it really shouldn't, to be honest. It's just a little bit. I got all those sides, and I guess I missed this one here. Yeah, all these are better now. Alright. That's better. But yeah, so that's why I didn't really put the idler in there, or the tensioner in there, because I figured I could get it tight enough with my hands the way that I have it designed. And the way I have it designed is it's just, this is a aluminum plate that I'm going to cut down, and then it just has these loops through it, and I just tighten it up by doing that. I never have had the need for wide tensioners on any of my printers. I've never once used them. I find them rather useless. I think people that need them have way too much tension on their belt, and I use bottom of the barrel cheap belts. Just my opinion. I don't think it's needed. So that's kind of where I stand on that. Is I really don't think it's needed. If you tension it properly, it's not too tight, I don't think it's really needed. I did create an X tensioner here just because why not? I might end up going back and just combining this whole thing and not having a X tensioner. But for now, I'm going to keep it. I don't know if I'll need it at all or not, but we'll kind of see. But yeah, I think that should be pretty good now. I think I have these sorted out, so I might reprint these X braces, I'm calling them, these right here, because my clearances were on spot, but these inner screw holes, which you just saw there, were off, so I had to redo those. And then the feet were off a little bit. I forgot to edit this side. Yeah, I forgot to edit this side, so I had to cut it down in order for the feet to fit in there. But now that's fixed, so that shouldn't be a problem at all. They all nest in there real nicely. Where's the front here? So you can see here how that just fits up in there, and then there's a spot, there's a hole through the middle for you to put in a T-nut if needed. I don't think I actually need one. Clamping this from both sides seems to be strong enough, but if I wanted a third connection point, I have it there, and I have it in the bottom of this one too, so there is that connection point there. Just in case it's not quite strong enough. Should be fine though. Who was it that recently made a video on belt tension? I don't know, Gunner. I did not see anything in my subscriptions, so it could have just been someone I'm not subscribed to, or I just might have missed it. I've been falling pretty far behind on my YouTube consumption lately, just because I've been so busy with designing this and building it and creating other videos. And speaking of which, I'm going to need to clean up tonight so that tomorrow night I can record for Monday, because I'll have video for Monday. I have an older video I could publish, but I don't really feel like it. I recorded videos a few months ago, maybe before I took a break, and I haven't gone back and published them yet. And I'm just kind of torn on publishing older videos like that for the sake of publishing them. I don't know. But yeah, I think this has been fun. I think that's where I'm going to stop it there. Oh, this is finished. This is the Mks Robin Iii Mount that I created for the Mks Robin. And it has integrated 2209 stepper drivers, which is really cool. I'm pretty psyched about that, because that means I don't have to worry about that extra part. See if we can mount this real quick. Smidgen short for this application. That works right there. And there is the base for the controller to sit. I'm definitely going to have to make some super short custom cables, I think, because, I mean, the drivers are all going to be lined up on this side here, and I'm just going to kind of be like, I don't need this is all, what, 5 inches of length of cable I need, so I'm definitely going to make some custom length cables for this printer, just because it is so small. Any cables that you buy online are going to be way too long for this. Even the Deltas, they come with short cables for their motors, because you basically have the controller and then all 3 motors around it for X, Y, and Z for the 3 towers on a Delta, and they have even shorter cables, but that's even too long for this. I mean, why? It's going to come across to here. It's going to come under the bar up to here. Power supply cable will come up. Power is going to be right here on this side. And all the steppers are going to be here, so I just have to route the gantry is going to be here, like so. If my x-axis is here, cables are going to come up, they'll come down, they'll wrap around the back side of this. I'll zip tie them there or something. Maybe I'll end up designing in. I'm not going to reprint these until I wire it up and make sure I see it, but I might end up adding maybe a little cable management on this back leg here. Something to go there that can hold those cables there. That way they're not constantly shifting across, they're not getting cut off by the Y, by the bed. So I need to think about that a little bit more though. These should be tight enough. Yeah, so these are just tight enough for me to thread in some M3s into there. But so far, it's looking pretty good. I'm calling this printer Master Crane, which is why I have a origami crane on it in a few different places. But yeah, I am super stoked with how this is turning out. Just have to wait a few weeks for the controller and things like that to come in, but I can have everything else done and ready to roll, and then once that stuff comes in, it's just going to be plug it in and try it out. But I can pre-make all my cables and things like that. Only one end stop, which is going to be right here as the end stop. Right here. It's going to sit like this. And that cable just run, again, this needs a 6-inch cable to get from here to here. It's a very short run to need for a lot of this. I think that'll be pretty good. Alright, well I think I'm going to call it there. It's been 2.5 hours, so I think it's been good fun. People got to kind of see how I'm designing mine and how I'm working through it, how I'm working through some of the problems I'm coming into. So I would say if you've never printed a printer before, or made a 3D printer before, print it in a cheap PLA or something like that. I'm printing directly in PETG. Most of my parts are pretty good, so I don't have to reprint too many of them. A few of them is a tolerance thing, but again, using a drill on here, easy to make these fit in there, and then now we're good on our length. Got that all the way down there with a hammer. Last little bit of persuasion on it. But yeah, so that works out, and yeah. So if there's any questions you have, let me know. I will say, I know my metronome here. If you do want to join the competition or the challenge, so again, the challenge is to create a printer with larger than a 100 by 100 by 100 print volume, less than $130. So I am currently today at $129.48. So I am just squeaking under. The only thing I did not include were springs for the bed. So I think I can find those for pretty cheap. Again, even though I have them, but if someone's going to need them, I definitely will be able to find something pretty cheap online and in order to do that. But that should be about it. Alright guys, well thanks for tuning in again. Hop on the Discord if you guys want to just chat, or again if you want to join the challenge. There's videos for that on the channel. There's videos for that linked in the 3D printer design challenge channel on the Discord. If you want to support me and do projects, there's some links down below to check out. Other than that, happy printing, wash your hands, see y'all next time.